All right, oh, no, not AP Stats. Pre-Cal 12, sorry. This is my fault. Pre-Cal 12, hope you're having a good day. This is review session 1. We're going to start on review unit 5, and we've got some people in here. We're going to get rolling, and hope this helps y'all. So let's go to the first thing. I wanted to start with something that really wasn't hit hard. I didn't feel like on the review, but it is on the actual test itself. So these two topics, like, write this down. This is definitely on there, okay? The first thing I wanted to talk about is the aspect of domain, okay? And so let's say I had something that gave me a function, and this is what this idea here is called a rational expression. And let's say that we had x squared plus 3x, minus 18, okay? And on the bottom, let's say that this was x squared minus 9, okay? Now, in this, we talked about this before, where we could find the vertical, horizontal asymptotes, the holes in this, right? We could even graph this. But within this part, and by the way, that is on the review, and that will be on the test. But this part really wasn't, where I said find the domain of this thing, okay? So any thoughts of what I could do to start this process? Yeah, exactly. Factor top and bottom. So this would be simplified on the top. What would I factor that to?
X minus, yeah.
X plus 6, x minus 3, right? And on the bottom, we could factor the bottom to x minus 3x plus 3, right? Anything crazy on that? Any questions on that? Okay. I will take it just a step further, just because we can in this, and because it is on the test. What can we do to simplify this? X minus 3, good. Does anyone remember what we call that if we cancel that out? A hole, right? So if we cancel that out, that's called a hole. And so what would we put in for the hole there? 3, good. Now notice there is no y here, is there? We don't see a y here. But we can find the y by doing what? Plugging back in both top and bottom, right? So if we plug into the top, we get 9, good, over 6, which reduced would be, yeah, you could put a decimal. You could have done 1 and, was it 1.5, right? You could have also just said 3 over 2. Any of those would work there. So we could do 3 over 2, and that'd be my hole there, okay? Now, are there any vertical asymptotes that are here? We got the hole out of the way, right? So we're really left, once we get rid of this part, we're left with x plus 6 over x plus 3, right? So we can write a vertical asymptote and a horizontal asymptote here. What would be a vertical asymptote? Great. Whatever makes the bottom equal to 0, right? We call that undefined, but really that would be our vertical asymptote. So in this case, we would say our vertical asymptote is x equals -3, okay? Good. Now, what about horizontal asymptotes? This is like the rules and stuff that will be on your formula sheet. You'll be able to have that there. But there's a horizontal asymptote that's to be had here, right? And to remember this, we look at the rule of what is the degree on the top? What is the degree of the bottom, right? And based upon that, we see what the horizontal will be from that, right? So what is the degree of the top? 1, good. What about the bottom?
1.
So if it's the same, what do we do?
Divide the coefficient.
Correct. And you'll have that. You'll have all of those there. So you don't have to memorize it. It's more or less just being familiar with where they're at to be able to do that there. So we'll divide x over x, which would be 1, right? Good. So we'd say y equals 1 would be my horizontal asymptote. Now, I don't know if there's one where I'm doing this much stuff on it, but it's kind of hitting a bunch of different things. So if you're like, man, this is a lot, it's because I'm doing a bunch of different things that you'd have to do on maybe different problems. I still haven't hit the domain though, have I? All right. What would be the domain of this? So after all this, what would be the domain?
All real numbers, but x equals -3.
Good. So we know that whatever makes the bottom equal to 0 restricts our domain, right? So I like what you said there, Torrance. You could say that the domain would be all reals except x cannot be equal to what? 3 and -3. Good. Kind of put it in this little thing here, which just means that the bottom can't be 3 or -3 because we've got a whole or vertical asymptote. So we would say it's all real numbers except those two values. Does anyone know how else we could write that? Yeah, interval notation, right? 2. Good. Yep. Yep, and 3 to infinity. Nice. And so this right here is the same thing as what you see up here, right? I would take either answer on that. But that's how you would talk about the domain there.
So is it based on the denominator or the whole vertical asymptote? Or is it going to be the same?
It'll be the same. Because if it's on the bottom, it's either a whole or a vertical asymptote every single time. So yeah, if you just set the bottom equal to 0, that's what's restricted by the domain. So the domain is always all reals except what makes the bottom equal to 0. Right? Cool. All right. Does that make sense? We're good? All right. I'm going to just ask this just in case. What if I said find the x-intercepts and the y-intercepts? Do you know how you would do that?
That y or x.
Good. Yeah. So if it's the x-intercept, what do I do?
That x. That yeah. The y-intercept. That the x equals 0.
Good. It's the opposite, right? And the y-intercept, you plug 0 in for x. I think that's what you said. And x-intercept 0 in for y, right? Okay. Are we okay on that? A little bit? Okay. Good. So that's part 1. Everyone feel okay on that one? Okay. That's not too bad. The second one, a little weird. Okay. You ready? All right. So I'm going to give you an example. Let's do, and everyone loves this, so I'm pumped up about this. You ready? 2 over 1, 4 over 1. I'm just making sure I've got 2, 6. Okay, and then up here with 2. Okay. Come up with the equation. All right. This is the tough one. Okay, this is the tough one. Now, I don't know if it's going to be like this on the test. I'm not promising that it's going to be this tough on the test. But if you understand this one and understand the background behind it, you'll be absolutely fine. Okay. Now, real quick, what's happening on the top? We're adding by 2. Okay. So if we're adding by 2, first off, we understand that there's 2 rules, right? One on top and one on the bottom. Right? So we know that if I say this, we have an a sub n equals, okay, something both a rule on top and a rule on the bottom. And because I'm adding by 2 each time, right, is that arithmetic or geometric? Arithmetic, right? Do you remember that? No? So like arithmetic's where like I add by a common number, right? Geometric is where I multiply by that. You'll have both of those on your formula sheet. You'll have both rules there. But because it's arithmetic, arithmetic rule is a sub 1 plus, what's up? Okay, n minus 1 times d. Okay? Trey, what I'm doing right now is, I just saw your shirt. Gotcha. As we're looking at this, these are 2 topics. The one, I'm actually podcasting this. Just make a note to go back and watch the first one I did. This second one, I told everybody and everyone on the podcast, there were 2 questions that I felt like that after doing the test, they weren't sufficiently hit on the review. So I just want to make sure I go over those with you and make sure I kind of you understand what's going on there. Okay? And then we'll go into that in just a second. All right. So when we look at the rule, we notice that it's adding by 2 each time. And we know that this is a arithmetic sequence, right? Okay. So that means what would be a sub 1 only on the top? Only look at the top part because we have 2 rules. Look at the top rule. And what would be a sub 1? 2, right? Good. And n, we know that n is just an n, right? The nth term. So we just leave n as n. What's the difference here? 2, yeah. We're adding by 2 each time. So really, we can multiply 2 times each of these to simplify. You see that? So we would get 2 plus 2n minus 2. Okay, I'll hold it just for a second. Is there anyone confused on where I'm at? Okay, so what does that simplify to there?
2n.
Yeah, just 2n. So the top rule is 2n. Okay? And by the way, because of the fact that it is not multiple choice, even if you don't get the bottom rule, just get the top rule. And I'm telling you, I'm giving you half credit right now. Okay? So you got half those points back. And if you get full credit on one like this, that's really, really good for where we're at there.
Do you want to showing work every time? It's like doing.
No. No, you can, if you see it and you say, oh, it's 2n, boom, put it down, you're good. I'm just showing you how I would get there if you can't visualize it, okay? Now, the next one, I don't know what else to say other than the fact that this one's just tough, okay? I will tell you, though, that whether you're watching online or whether you're here, the bottom sequence will be on the test somewhere, okay? So all I can say is it's tough, and I know it's tough, but it will be on the test somewhere. So just kind of note that, put it in bold, circle it, do something that's it's going to come up somewhere here. So as we look at 1, 1, 2, 6, and 24, am I adding by something that's in common? No. Am I multiplying by something that's in common? No, right? So it can't be arithmetic, and it's actually not geometric either, okay? Does anyone know what the pattern is? Yeah, so we multiply by 1, multiply by 2, multiply by 3. There you are.
Well, that's
4.
the question mark.
Boom. Yes.
Oh, yeah, exclamation point, right?
Yes. And if you remember that, that's all you need to do, okay? So I would just say be careful because what Trey said is true. An exclamation is there. I would say before I say that it's set in stone, just try it real quick. So like if I plugged in 1, I would get out 1, right? Plug in 2 to exclamation, I would get 2. Plug in 3, I would get 3 times 2 times 1, which is 6. Good. You see where we're at? What's wrong with this matching up to that? There's an extra one. Yeah. You see that? So I need to go backwards 1. Does that make sense? So Trey, you were right. I just need to take this and go back 1. That's it. So what I'm going to do is this. There you are. N minus 1, exclamation. And then that's it. That's all you've got. Okay? So just recognize that pattern, just like y'all did well. Okay, y'all did that great. But just recognize that pattern with the exclamation point there. And just remember that. Just test it real quick. Just test it. So that when you see it, you just say, oh, I just got to go back 1. That's there. So let's say you did just do an exclamation. You'd probably get 3/4 of the credit that was there on this problem. But to get the full credit, you have to recognize on this one that it would be going backwards 1. Okay? All right, those were the 2 that I felt like I wanted to hit on real quick before I went to the review, were ones that I felt like we needed a little bit more reps on before we went to the review. Any questions on either of those 2? Feel okay? All right, so Trey, we are podcasting, so we're going to go through Unit 5 first, okay?
Cool.
We're going to go through Unit 5, and so if y'all have any questions, we'll just start by going over any questions you have on Unit 5, and we'll just keep podcasting. When we do other study sessions, we won't repeat these. So if someone has a question on them, I'll do them, maybe individually, but I want to make sure it's podcasting unique stuff on there for everyone. All right, so any questions on Unit 5? Let's do it. All right, so do you have any strategies that you would take on like number 2? Do you have any things that you would think of? Yeah, like graph it first. I like that. So just draw it real quick, just a sketch. So let's do that. Let's go. Let's try it out. Let's go. Okay, we got -3, 2. Okay. So this is our vertex. And we note that this is a parabola, which is important too. The directrix is y equals 5. Is that left or right or up or down? It's left or right, right? And if you forget that, because it's hard, because usually you think y is up and down, right? Go on the graph. Where is y equals 5? Well, we have 1, 2, 3, 4, 5. It's right here, right?
You gotta go.
And then that tells you that it's going left and right. Kind of helps me. Okay. So if the directrix is here, the vertex is here, what we can do now is identify where this graph is going, right? Where would it be going? Well, remember, this is the GAC line, right? Okay? That's exactly, except y'all. Y'all are dedicated. Y'all want to be here, right? So y'all are going to go away, right? We're going to go downward from this. Now that helps me because that helps me to identify which is being squared. So would it be x or y that is being squared on that? The x is being squared. And because it's going downward, is this going to be negative or positive?
Negative.
Negative. So before I do anything, here's how I would do it. I would just say that, okay, this is going to be x minus h squared equals 4p times y minus k. And this will eventually be negative. And maybe I just circle that to identify that there. Okay. So what else do I know?
No.
Okay, what would be the foci? That's a good point.
-3,
-3, -1, which is a distance of what from the vertex? I like that. So -3, -1. And how did I get that, Kendall?
It's P, which is the same as for the directrix.
Good. So P is the same on both sides. What's up, Scott?
That's okay.
Good to see you, my man. Yeah, so the P would be 3 here, which goes both up and down. And that helps me to identify what would go in the equation, right? So what would go in for H here?
-3,
Good.
-3.
Yeah, so -3, which would be +3. So we have x plus 3 squared equals, what would go in for with the -4p?
-12.
-12, good. And then times y minus 2. That'd be my answer. Scott, right now we're podcasting. So as you go through, just we're starting on unit 5. The reason why we're starting on that unit is we'll just kind of go backwards. And that way when I podcast, we can do maybe some different stuff for everybody. Before this, I did have 2 problems that I did that were not on the review, but will be on the exam. So just go back through and check it. That's what I would do. Okay, number 2, we're good? Yes. Sweet. Okay, what's another one?
Three.
Let's do it. Number 3 is a tough one. I think I've got maybe one of those on there. One like number 3. No, by the way, number 8, cross off number 8 as well. Number 8 we never talked about. So no worries on that. Also, as you go through these, there are some of them that say with a calculator and without a calculator, okay? So it's important to note that when you go through that, make sure you note that. So if it says without a calculator, practice without, because there will be a calculator and non-calculator section. Just be leery of that. Okay, let's go through number 3, and let's do it together. Let's go. Okay, so what would you do first here? Yeah, x's and y's, right? So we'll go 4x squared minus 32x and we'll pair the y's together here. So we got 18y. What do I do with 37?
Move it over.
Yeah, move it over. Got negative 37 there. What next?
Take stuff out. Or like, you take out 4 from the left side.
Yeah, so we're going to take out something in common for both of them, right? So we're going to take out a 4. And what am I left with?
X squared minus 8.
8x, good. And what about here?
Y squared plus 2.
Nice. Good.
You half of the square, right?
Mm-hmm. Which would be?
16. And then 1 on the other side. Then you have to do it to the right.
Yeah, so if I do this to this side, right? What do I have to do to the other side? This is the tricky part, right?
Oh, put those numbers on the other side.
Yes, kind of, but it's not just 16, right?
You should multiply by the number.
Good, so it's 4 times 16, right? That kind of goes together. So really, what's the number that I add to the other side?
64.
64, good. So we got that there. And then not just this one, but really, what is it? 9, good. Put 9 here. And traditionally, this is going to work out 4 times than not, right? Or every time on this one here. So we have 4 times. What's the perfect square?
4.
Good. Plus or minus?
9 is
X minus 4.
X minus 4 squared. Good morning, Caleb. How are you? You look nice today. So x minus 4 squared. What about the inside of this one?
Y plus
1 y plus 1 squared. Good. And what does that right side turn into here?
46.
Yeah, good. 46. Is it 46?
I think so. No. It's 36.
36. Yeah, yeah.
Sorry.
I was like, that won't work out if I did it that way. But it's equal to 36. And now I need to do one more thing here to get it equal to our standard form. And that would be what?
Divided by something. Or
Divide this by? Yeah, dividing the 4 and 9, divided by 36, right? Into the 4 and 9 here. And so really what 4 goes into 36? 9 times, good. And 9 goes, yep, 4. And this is just simply 1, right? So what we have now is our standard form would be x minus 4 squared over 9 plus y plus 1 squared over 4, and it equals 1. And that's our standard form there. Now, there is one on the test where you're going to have to graph it and come up with all of the logistics of those, okay? So know that for parabolas, know that for hyperbolas. You'll have the formula sheet like we did last time. In fact, I think I've got, if you wanted to take a picture, did y'all get this formula sheet here? Okay, let me make sure. If you did not, you can feel free to take a picture of this. I think I even have a more updated one than this, but go ahead. That's a good start there of ones that will be both front and back. But again, once I get this here, now we've got to graph it, which what would be the center?
4.
Good, 4, negative 1. There's the center. How far up, down, left, and right do I go?
Up 9.
Close.
Up 3.
Up 3, because we have to square root it, right?
Yeah.
And it's actually not up, it's
Or it's to the left.
left and right because it's underneath my x, right? So we go left and right, 3. Good. And how far up and down do I go?
2.
Good, 2. 2 up, 2 down. And since this is an ellipse, right, because this is plus sign there, we just simply put the ellipse here. And where would be the major axis? To the left and right, or to the up and down part?
Left and right.
Left and right, because it's greater, right? Yeah, it's greater here. If it's a hyperbola, it's a little different, right? Because if it's the whatever one's first, that's the major or the vertices. But because it's whatever the larger one is here, you would say those two spots, those are what we call our vertices, right? Got our vertices there. And then our foci are always inside of my vertices. So they'll be here and here, okay? And mine's not drawn to scale great, but you'll have stuff to be able to write, put that down on. So my the center we've got, the vertices would be to the left and right 3. So this would be 1, -1. And then over here would be 3 to the right. So 1, 2, 3, 4, 5, 6, 7, -1. So this is 7, -1 is a vertice over there. How do I find my foci?
A squared equals, maybe the c squared equals a squared minus b squared.
Good. A squared minus b squared. And we remember that by looking right here. Whatever is if it's plus here, then you would subtract a squared minus b squared, right? If it was minus, we would do a squared plus, right? Good. So this would be 9 is a squared, right? 4 is b squared. So what is c squared? Say again?
Is that one in the formula sheet?
It's a good question. Is it
I
on
don't
there?
see it on there.
Did I not put it on there? Tell you what, let me I'll double check that, okay, Trey? Because what I'll do is, if not, then I'll come back to that.
Like the last test, we got to like add like the APs and C's and like what was on those on things.
Sure.
So if we have a worksheet, can we add that to it? Or?
Let me look in the foci. Probably we'll do the foci. Cool. Like which one? Like the foci is related to it. The formulas are on there, so you actually have the equations on there, and it'll have those there. The other stuff, probably not. But the only other thing I could really see as needing that was on the charts, other than just a picture, which I think we'll be fine without, is that foci formula. So that's the only thing that is not on the sheet that I would say. No, I'll put it on there. Or what I'll do is probably before, because you get a fresh sheet on there, I'll probably before just say, hey, before we begin, here's the foci. Here's the one for ellipse. Here's the one. What's up, A-Train?
Do we just use the formula sheet you gave us after that test?
They should be one and the same, meaning the one of the sides, if you flip it over on the other side, is there one that's similar to that?
Yeah, I wrote.
Yeah, I would say on that, the only thing that I was telling Michaela, the only thing that I feel like you really, really need for this test, in terms of graphing and stuff, is it already tells you what's the hyperbola, what's the ellipse formula, just which is what foci do I have? Like, what's the foci formula, I'd like for you to know how to apply it. So if you had like example problems or something on the last test, I would say we're going to go away from that. But for the foci formula, I would give that to you. So which one would be associated with ellipse, which one would be associated with hyperbola. Other than that, I don't know if we would need it too much. Does that make sense? Let you come up with something and I'll think about it. But I think that if we just put the foci formula down and we remember that, we know the center, we're good there. We know once we get the center, whatever one's underneath, we square root it to go left and right, one underneath x and up and down with one with y. If it's a plus sign, we know it's an ellipse, so we just make that circle that's there. The vertices are the one that are on the major axis. Put those there. Big thing is what's in yellow. Okay, how do we remember the foci formula is a squared minus b squared. So we do that, which I don't think we've done yet, but we would take that and get the square root of 5, right? So from my center, we're going to go plus or minus square root of 5 left and right. So if my center is at 4, -1, right? Is the foci going left and right? Is it changing on my x or changing on my y? My x, exactly, because it's going left and right from that's where my major axis is. So we can just say 4 plus or minus the square root of 5, comma, -1. And that would be sufficient. So I could, like I said earlier, that's the part that I think I could see myself giving to you there. And I believe on the test, I will say like, hey, this is a parabola, or this is an ellipse, or this is a whatever. So you'll be able to see that there, right? At least on the formula sheet for sure. That's a big one, isn't it? Big one. I would say that's a tough one. Questions on that? Does everyone know the minor axis points? That would just be up here and here, right? Right here, which went up and down too. Okay. Those that just came in, Michaela and Alex, I'm podcasting this right now. So some of the stuff that you missed, I would say they were the first two questions after taking the test I did myself this past week. There were 2 questions that I was like, they really weren't on the review. So go ahead back and check out the podcast, because those first 2 questions will be worth your time for sure. So just 2 that I would say go check out. All right, any other questions on Unit 5? Y'all see?
On number 6, what do you mean by characteristics?
Yeah, good question, Trey. I would say on that one, I don't like that as much, because I like to actually list out the things that I'm talking about. So like if I say, what are the vertices?
Like just that.
What's the center, right? What's the asymptote? The asymptotes that are there. Are those asymptote formulas on there? I don't think I did I? I will tell you this, the asymptotes, I am not going to give you that formula for the test, because it's not a required part of the test, right? Might be a good, it might be.
There's bonus on this.
There's a couple challenge questions that I've extended, like where,
Like each unit or-
I wouldn't say for each unit, they're kind of towards the end. So just they're kind of the extra stuff. Maybe some things like slant asymptote, right, would be a good thing. What I just said, the asymptotes for
What's the formula?
the asymptote formula. The asymptote formula is y equals k plus or minus rise over run times x minus h.
Is the test gonna be like organized like in each unit, or is it gonna be like mixed up?
Yes, I think it is kind of mixed up. Yeah. But I'm not trying to trick you. So what I mean by that is the topics that are on the review, I've kind of narrowed it down. What are the topics that I really want you to know? And I would say just know the topics on the review. Okay. I know there's a lot on the review. I know what there is, but I've seen longer reviews as well. And I would say just know the stuff on the review. Know those topics. You know those topics, you'll be perfect. Okay. So Trey, do you want me to go over number 6 or?
Yeah, sure.
Good. Okay. So what about the center? What's the center for that one?
0, 0, 0.
0, 0. Good. And like Mason said earlier, I like to graph it. Just makes it a little bit better when I start graphing it here. And how far left and right am I going to go?
Left. Or left
2.
side, 2.
Yeah. So 2 here. 2 here. How far up and down am I going to go? 1.5. And it doesn't have to be perfect. We just know that it goes down and up square root of 3, right? Because remember, we have to square root that value, just like we square rooted the 4 to get 2. So right here, is this going to be an ellipse or hyperbola?
So that's hyperbola.
How do I know?
Said minus.
Does say it, and then also because of the minus sign, right? So that's definitely something as well, okay? Both of those things are true. So once we do that, we've got our box. Got our box. We've got our asymptotes that are here, right? If I did say what's the asymptote here, you could do that. What is the H and K?
0.
0, 0. That's exactly right. So because it's 0, 0, we could just say nothing, right? So really you're left with plus or minus rise over run times x, right? And my rise over run is I rise how much? Be careful. I rise 1.5 square root of 3, which is what square root of 3, right? And I run how much? 2. So rise square root of 3 and run 2. So my asymptote is plus or minus square root of 3 over 2. Have a great day, Mason. Torrance, have a great day. Have a good one. Be blessed, juniors. Are you not laughing at him? Is that what you're feeling? Giving him a hard time? Is it weird?
Yeah, it is.
Yeah, it is a little weird. All right, so again, once we attack that, we would just say y equals plus or minus square root of 3 over 2 times x. Cool. For the asymptote that's there. Okay. What about the where do I graph this? Left or right or up or down? Left and right. Good. Yeah, because it's what? Because it's first. Good. Be careful. It's not which one is the largest. It's which one is first in the hyperbola.
Which one's
Okay.
the one?
Let's have a go, man. Have a good day.
Which is one of its largest?
That's the ellipse. You graph it the same. I mean, it's the same thing. The only difference is with an ellipse, I graph the large, whatever the one's the largest is the one that's related with the major axis there. Remember too, these 2 points, what do we call these 2 points? Vertices, good. So we could say 2, 0, negative 2, 0, right? Nice. And characteristics, it's kind of vague. It doesn't really tell. I mean, you probably could find like the foci, right? And the foci of this, does anyone know what the foci formula would be?
A squared plus B squared.
Good job. Good, Alex. And what's A squared? 4. What's B squared? So it would be 7, which would be the square root of 7, right? On that. And with the square root of 7, would that change on my x or would that change on my y? Good, x. Why would we say x? Yeah, it's because it's first. I like that for a hyperbola. It's really inside here, right? What's up, Jacob?
Oh, yeah,
Good to see you,
yeah.
man. Thanks for coming today. So yeah, since it's inside, right? Since it's inside, we would say that it would be plus or minus square root of 7 would be first, right? So we would say from my center, since it's 0, 0, what would be my foci? Comma 0, right? And that would be my foci. That's really all my characteristics there. But on the test, I think I pretty much say, hey, these are the specific things. Go ahead and find those. Okay? All right? Right here, plus or minus 3 square root of 3. Yes. Yes. So Jacob and Christian, good to have you here too. I forgot to say hey there. When y'all came in, I didn't mention this yet, but this is being podcasted. There were 2 questions that I started off this podcast with that I told everybody, just go back and double check on those. There are 2 problems that out on the review that I wanted to make sure I went over. So just make sure you go over those at the beginning of that podcast. We're starting on Unit 5 because I felt like everyone said that was something that we could maybe start with. And right now we're on number 6, and we're just kind of answering questions there. If we pick one that we've already done on there, I'll just say, hey, I've already done that on the podcast. Just go check that out just so we can continue to have unique things on the podcast. Or we can do it one-on-one later on too as well. Okay? Cool. Thank you all for being here. I forgot to tell you that. Thank you so much. Appreciate it. Questions? Unit 5. Any other questions on that?
Yeah, 7.
7? It's a really good one. And then I also, Jacob, just before you got in here, said something about asymptotes. Like that would be a really good challenge question. Slant asymptotes would be a really good like challenge question. Kind of takes it a little bit above and beyond. So just something to keep in mind there too. Let's go to 7, and we'll go from there. And number 8, throw out number 8 too as well. Throw out number 8. Write the equation for the hyperbola as a center at, there we are, boom. Center at -3, 2, and it opens right and left, and it's a distance between the vertices is 6, and a slope of the asymptotes is ±4/3, okay? All right, so what do we do first?
Plug in this.
Good, plug in the center, I like it. Like plug it into the equation that put on the graph too. Okay, so we'll go -3, 2. Put that there. Okay, and would x come first or y come first?
When it goes to the left.
It's if I put it to the right. Yeah, that's my fault. Yeah, so we're gonna go left 2 or left 3 and up 2. Is that right? Yeah, there we are. And it's gonna be graphed left and right, so x comes first, right? So what would that look like?
X plus 3 squared.
And then minus or plus?
Minus
Minus.
y minus 2 squared.
Mm-hmm. Equals 1. Good. Okay. Now we just need our a and b, right? You said 9? Why is that?
I
True.
think it's -16.
Because it's the asymptote.
16?
The rise and the run.
Yeah, so we could go to the asymptote, which is rise over run. So I rise 4, run 3. So if I run a rise 2, 3, 4, rise 4, and then I run 3, 1, 2, 3, right? That means this is the top right corner. You follow me on that? So that means that this is the top right. Therefore, it kind of mirrors over. So it'll go down 4. So 1, 2, 3, 4. And then over 3. 1, 2, 3. So this is like from corner to corner right here. Okay? So this would be like what our box would look like. Something like that. Okay? So if I rise up 4, that's what I got here, and I run 3, what would be my A? Y'all said it, I think. Exactly, because that's what I go left and right, which is underneath my X. So if this is 3, what would this be then? 9, and this would be 16. Good. And that would be my equation. X plus 3 squared over 9 minus y minus 2 squared over 16 equals 1. Does that make sense, Jacob? Good stuff. Anything else on Unit 5?
Wait, how did you get 16?
Oh, gotcha. So we rose 4 because it's rise over
Oh,
run.
yeah.
It's a good question. Y'all see the highlighted stuff too on your sheet right there? I'm not saying that's not the only stuff that's on there, but that's the stuff I would say really, really know. Got me? That doesn't mean ignore the other stuff, okay? But really, really know the highlighted stuff. Just saying. Did you hear that?
Yeah, got it.
Really know that. All right. Any other questions on Unit 5? How do we feel on Unit 5? Not good? Jacob, what do we not feel good on?
All of it.
Is it more or less like, well, I know you did come later too, so that could be 2 if you wanted to go back through and check. Are they the ones where, like where I give you an equation, like look at number 1, if I gave you one like number 1, I told you it was a parabola, right? Do you feel pretty good in getting it into standard form, or not really? Kind of. You want to do that one?
Yeah.
We'll finish unit 5 with number 1. Is that cool? The only reason why I say that, Jacob, is we did go through numbers 2 and 3 here, and I think we went even through another one too, like number 6. So feel free; those 3 might be good as well. I want to just see how far you can go with number 1. Is that cool? So parabola, right? We got that. What would you do first?
Get like 8x plus minus 15 to the other side
Good. What would that turn into?
equals negative 8x plus 15.
Good. What would you do next?
You can't take anything out of it, so you can take out y.
You kind of could, right? Yeah, you're right with that. I would say maybe to make it easier is when we want to try to get in standard form within any of these, we're going to complete the square somehow.
Okay.
You know what I mean? So what would I put here on this left side?
Plus 1. Yeah, plus 1 is half 2 squared.
Yeah, exactly. So what I do to one side, I have to do to the
Then you have,
to the other. Just a heads up before I continue. If you remember too, sometimes when you complete the square, there is a number on the outside. Let's say I had something like this where I half and square it. What I do to one side, I would do to the other. But just be careful because that 1 is really multiplied by 2. So just be leery on that. You'll see that on number 3 that we did. So if you want to just check that out on the podcast, I go through that a little bit more in depth as well. So what would we have left over?
you just have negative 8x plus 16.
Good.
And you can bring an 8 out, x plus 2.
And because we want x positive, we could just make it
Negative 8.
-8 on the outside. And that way x is positive. But what does that change 16 to?
Negative 2.
-2. Good. And then what about the left side?
1 plus 1 squared.
Close. Y minus 1. Good. Good. Just those little details like that, just be sure to double check those, okay? The test is like 30 questions, so it's not crazy. Well, it's all free response. There is a point, like people do better on those. So
Are you going to be grading for partial credits on these?
absolutely. That's why I do it. Yeah.
Is that the answer?
For the standard form, you're exactly right. So we've got this part. The next thing we've got to do is find this mess right here. Okay. So Jacob, what would be the center of this?
Positive 1, 2.
Good. And what would come first?
2. So 2, 1.
Nice. So we've got that, and I'm just going to draw the picture because sometimes that does help me. So we've got that there. What would be the p-value? This is it'd be 2, right? Does it matter on the sign? I always write it positive. If you put it negative, you're okay. I don't ever take that off, or at least this one. But we know that this -8 is, with standard form, equal to 14, right? So Michaela just divided that by 4. Does that make sense? And
Yeah.
Jacob, you'll have that form, all the formulas and stuff on there. So P is 2. And because y is being squared, is that going to go left, right, up, or down? Sure on that?
This question, sorry.
Where is this direction of this parabola going to go?
P always positive?
I always write P as positive, but if you put it as negative, that's okay. That's okay. The only reason why the negative comes into play is it tells me the direction, right? To and left and right because of the y squared. Good. And because it's a negative, that tells me it's going towards the left side. Okay? You want me to say that again? You want me to say that again, Jacob? Okay. So I look and see, once I get it here, which, Jacob, you did a good job of that, it's now asking the question,
How do you go to the left side?
Yeah, so when it's y squared, right? What does that tell me? It's left to right, okay? If it is negative, that means it's going to go towards the negative values. If it's positive, it's going to go towards the positive values. So that means this is going to go this way. Cool. And because this is -8, how do I get P again? 5 by 4, is everyone good with that? So we know P is 2. So is the foci going to go to the left, or is it going to go to the right of my vertex? The left, right? Because it's always inside of it. So when I do that here, I go 1 and 2. That's my foci right there. And what goes to the right side?
Vertex 2.
Vertex 2, right here, right? This would be here. So what would be the directors?
4.
4, good. X equals or Y equals?
Y. Or X equals.
Yeah, because it hits the x-axis there. Good. So x equals 4 is my directrix, and my focus would be 0, 1. Good.
What does P mean?
The more part.
So P is just the distance that you gotta find the foci.
And the distance, so the distance from the vertex to the focus, and from the vertex to the directrix.
Focus and foci, that's the same.
Say it one more time, I'm sorry.
Focus and foci is the same.
Foci is like 2
Just
focuses.
two. Okay.
Does that make sense?
So the
So
focus
yes.
is 0, 1.
Correct. That distance and that distance is the same. That distance and that distance.
So basically for P, P found P, and then from our center, we went that direction to the left.
Left and right. Good. Yeah. Exactly right. Cool, cool. Questions on that? Jacob, does that make sense, what we were talking about?
Yeah.
What would be as we're going through it, is there anything that you think you might get tripped up on?
Oh, really? So those feet up here.
The P
Yeah.
stuff? And that's probably legitimate. I understand completely. I would just say one of the things that helps me out is when I draw as I go. I don't know if that would help you. But as you go, just the things that I find, just drawing it, putting it up there, that may help you. I don't know. That may help you there.
Can you explain the focus one more time? So the 2 comes from like, left 2 from your center,
The
right?
standard form of this is y minus k squared
Oh.
equals 4p times x minus
Oh, so the
h.
P is how much you go. Okay, all right, makes sense.
So I always set 4p equal to -8,
Oh.
or whatever that value is, to find what the p value is, the distance from my center.
And then you just go, when you graph it, you just go left 2. Focuses on the inside of the graph.
Exactly right. Good. What's up, Dory?
Hey, good
See-
day.
Good to have everybody here. This is like a party again.
Yeah,
Look at
it's
y'all.
a big old party cushion.
I know I keep saying it. Those that I've heard it 100 times, I'm sorry. But I did 2 problems at the beginning of this
Okay.
podcasting it. So if you missed part of this, you can always go back. But there's 2 problems. Check out the first 2. There were 2 that weren't on the review that I just said I was very specific. Just be sure you know these things. So just make sure you go back and check those out. We're wrapping up Unit 5. So you can go back and check out Unit 5 on the podcast. We can do them individually on an individual basis if need be. But we're going to keep trying to go through other stuff so you can always go back and check those other ones out. Okay. Anything else on Unit 5 that we haven't hit on?
Well, it only goes to Unit 5.
Say again?
It only goes to Unit 5.
Yeah, that's all we had for this.
No, the 9 is to see.
No, we can go pull back from the other, semester.
We could not though.
Wait, honestly, I don't even remember. I don't think I
We could
remember anything
do
with the first
last
semester.
instead of.
So this,
That's it.
Yeah, we do that.
I do like last semester.
What did we do last semester?
I don't know if
even
it was easy.
remember.
I know I had
Trick. It was all trick stuff.
I
Sine,
had
cosine, tangent.
I had 10 points better in Scott.
It's always helpful.
It is tougher. There's a reason why we do,
Why do they do the hardest of second semester when no one cares?
because of the college placement exam. All of this stuff is college placement exam.
What if I
Well, my college placement exam is not going to go very well.
What is that? On the staff, you took
Your school science.
Mine is online.
Yeah, mine's online.
I only have to take one
Or-
semester
I'm just doing it online, I'm doing it.
Okay, so, how we doing? Unit 5, we kind of bottled up Unit 5 there, okay?
Yes.
I know it was a lot. There. But we've got 1/5 of the stuff that we've covered. I would just say keep going through each of the problems that you see. Just understand the concepts as we go through. And if you have questions, let me know. Parker, do you have any questions there?
On Unit 5? Or just in general?
In general?
Oh, no. Can you go back over
Stars.
the calculator, like projectile thing? on
Oh,
Unit 1?
yes, number 1.
Number 1. Also, my calculator's dead.
Okay, so you want to start in Unit 1? Are we good with that?
Yeah, let's do it.
Yeah.
Okay, so we got Unit 5 dominated. Okay.
Dominate.
We'll say that right now.
Yeah.
We can always come back, but let's start on Unit 1 and go through that stuff, okay? Unit 1, problem 1 is on the exam, 100%. Okay. So let's do this here.
Is this basically our exam?
Conceptually, yes.
Okay.
Conceptually,
Not like
yes.
number for number, but like.
Yes. I mean, I'm not trying. I told them earlier. I said to everybody, I'm not trying to trick you. These are the concepts that I want you to know. So let's just make sure we know those concepts. I'm not saying that it won't be exactly the same because it might tweak things up, but you understand conceptually what's going on. You should be fine there. Okay, so let's do this calculator one here. When I kind of get this up. So this is number 1. I write this down. Okay. So it says here's a projectile. I'm just gonna 32x squared. I'm guessing everyone's good with at least plugging it in, right?
Yeah.
It's just what I do from there.
Yeah.
Anybody see something weird?
My favorite.
It should be a projectile, but
It's really not, right? What I like to do is just and if we can get kind of the cookie cutter of what to do here from this to this, it should work on every one that we'll experience on the test. So when we go to Zoom, let's all just start here just so we're on the same page. Let's go Zoom standard, which would be 6 here.
But you have extra graphic calculator?
I do. Got one right here.
Thank you for that.
You welcome.
Oh, this is so much easier than mine.
Again,
He needs help with his calculator.
what did it say? Does it say anything on there? Oh, there's dots there. I'm gonna go to the second one. We just want to turn that on. Okay.
It's charging.
Okay, why does mine look totally different than that?
You just go to Zoom standard.
I'll take this.
Oh, that's okay.
That's how it's supposed to look.
Yeah, because right now you're just a step ahead of me. What you're doing is you're seeing what's happening on the graph, right? So basically, if I were to go to Zoom Fit, which is if I scroll down, it's like at 0. It could look something like this. Yours may look a little different on that. Some of you may see parts of it, like what Jacob has, but you'll recognize that this doesn't really tell me the full story yet, okay? So what I want to do is, do you see how I want to back up? Like if I could, which would be awesome if we could just basically like on an iPhone, just like pinch it out, which is probably what will happen like next year, knowing y'all's luck there. But what we'll do is we're just going to back up from here, okay? That's all we're going to do. So to go here, we're going to go to Zoom, and I want to zoom out. Jacob, you'll do the same here, okay? Now, do you see that little cursor right there?
Yeah.
Okay. Basically, I can navigate this left to right, up or down, wherever I want to, and wherever I want to zoom out. So if I really want to zoom out here, then I'm going to put this in the bottom right-hand corner. And anytime that I press enter, it'll zoom out at that spot. So if I press enter here, it'll zoom out and give me a little bit of a better picture. Do you see that? And you see it, I still don't see where it hits the x-axis. Just one more time, I'm gonna just scroll down to this bottom side here. And
Oh,
just
there we go.
put it right here. Do you see it? Just want to zoom out. Just press enter. I can keep pressing enter how many ever times I want to. If I do it one more time, then I can get the full picture of what's going on. Okay?
And that's on Zoom Fit, right? And then you just keep fitting it to your screen to get to it.
I did Zoom Fit to start it, and then I go to Zoom Out.
Okay.
Got me? Zoom out on that.
Coach Jay, I'm not getting any like lines on the graph at all.
You see?
This guy is like effective 13.
So when you go to Zoom,
Yeah,
go down. Oh, then that's a good start. But then go to Zoom Fit, okay? Because then that's a good start with where you're headed. You see what I'm saying?
Yeah.
But that's like, then you want to zoom out over on that side.
Okay, yeah.
All right, is everyone good? All right, let's do this. Here's the first thing I'm gonna, before I go and like solve for all the questions, let's talk about this. How far from, so before we go through this, there's a guy on a cliff, throws something off, right? Okay. Kills a lion with his bare hands, throws the head off the cliff. Okay.
Right, okay.
All right.
Yeah.
All right.
Does that happen?
Throws it off the cliff, and then it lands in the water, which is the x-axis. You see the picture? Everybody
My,
good?
did I put it wrong? Because mine is not above.
So you're really focused in there, okay? So yours is the opposite problem where you're like way, way back. So to get a little bit better picture, go to Zoom, and then go to Zoom in now. And then press enter right at the inside. Let's see if it kind of helps.
Is this line right here the x-axis?
Should be the x-axis over there. It's kind of
Or the one, yeah.
Mine's like a little bit.
yours the same one. Man, look at it real quick. If that ever happens again, y'all, here's what I would do. I would go just straight to Zoom. You go start at Zoom standard one more time. Okay. You won't. You may see something there. Oh, did you put? What'd you put in for that on the y equals? Negative.
Okay.
Yours is just off by that. But then once I go to Zoom standard, once you plug that in right, put it into Zoom standard, and then go down to Zoom fit. 0 there. And then after that, then you can kind of zoom out like what I was doing earlier. Does that make sense? That way, if you do it that way, I find that gets you the right answer more times than not. So again, there's a line head that gets thrown off into the water, okay? And so the questions that it asks is A, how far from the base of the cliff is the height of the projectile a maximum? All right, so I hear one word and I automatically think what? What did you hear there? Maximum. Let's find it, okay? So to do this, we're gonna go, what's up, Nicole?
Hello.
You wanted to join the party?
Good.
By the way, this is completely random, but I saw you, so I have to talk about it. I finished that book.
Oh, you did?
It's better than the first one.
Really?
Yeah.
Oh.
So we're gonna go to second trace. We're gonna go to maximum, okay? And then, does everyone know how to find the maximum once I get here? No? So everyone goes to second trace here, right? Which lives in this world, right? And then it says maximum, so we go to maximum. And then left bound, what does that mean?
To the left.
To the left.
To the left, to the left. Everything went down. Yep, to the right bound, right?
And then you hit it one more time.
Correct. And then we guess.
Bang.
Boom, there's the maximum. Okay.
Riveting.
Riveting.
Wow.
Riveting. This is riveting.
I have a question.
Yes,
I
Nicole.
know I'm like really late, but
Cool.
what formula? Like, do you give us a formula sheet on the final, or do we bring one?
Yes, I've got a formula sheet for you.
Okay.
So before, I think Alex has one. take a picture of that one. I think I've modified it a little bit, Nicole.
Like this one?
Yes. Take a
Oh, I
picture of
see.
it. I've modified it a little bit.
Okay.
Maybe I can get you an updated one.
I can get one of those too.
Yes, I've got to find where they're at in the updated ones. But yes, I can. Just remind me in a little bit. Okay, so let's talk about what the maximum is saying. Okay, the x is how far away from the cliff it hits a maximum. Does that make sense? So like if I throw something in the air and it like creates a parabola, the distance of x is the distance from the cliff until it hits the maximum height. Does that make sense? The y would be the distance from the water where it hits the maximum. Y'all follow me? So what would I put in for A?
Is this for part B?
It's kind of both. I think it's both, right?
A is how far from the base
Bingo. So that would be
would
1.56,
be
right?
the X, and then B is find the maximum
200.
height. And it's the Y?
Correct.
Okay, so,
Good.
okay.
Good.
We like explain that all again.
Which part, Alex? Do you see it on your calculator?
Yeah.
Good. Did you see the x and the y from the maximum part? Did you see how to find that? So go to second trace up there. You'll see like you start living in this world right here where if you go to maximum here, which is 4, this is where you go left of the maximum, press enter, right, press enter. And then somewhere in the guess, which is in that center, to get what the values are there. Does that make sense?
Sherry, let have a new sheet.
Don't think so. Mainly because the formula sheet is pretty thorough in terms of what I have on there. What's that?
Stick.
Oh, no. Too early.
I'm not going. Yeah, we'll stop there. All right.
So
that was weird. All right. So, Alex, are you good so far? You understand what part A and what part B is with that?
Nope.
That's fair. So, if I'm on a cliff, right?
Oh man, wait.
I
I'm
know.
so serious.
And if I throw something off, right?
Throw your ring off.
The distance, the distance or the height of it, okay, would be the 200.78. The distance from the cliff to reach the height is 1.56. So what is 1.56 going for? Correct, which is part A or B? Nice. Part B would be the, there you are. Yeah. Good, good. Is everyone okay on that?
Yeah.
All right, let's look at part C. How far from the base of the cliff will the projectile strike the water? What's that? Just the 0 value. Good. It's right there, right? Where it hits the x-axis. So we live in the same world, right? No, not math. I'm sorry. Second trace again. We're going to go down to 0, just like Dory said there. Press enter. And remember left bound, right bound, guess.
Wait. What was the thing you just right before that? What you do?
Second trace, and then just the 0 right there. And then just go left bound. Press enter. Remember right bound's got to be below the x-axis there. And then the guess is somewhere in the middle. All right. And 26.61, right, is the feet from the base of the cliff to get that there, okay? If I say draw a model for this, would y'all be okay with that?
What?
Yes. Which is just a fancy way of just talking about what's happening.
That?
Yeah.
Oh, yeah.
So remember, this is like over here, that's the cliff, right?
Right.
Oh, that was funky.
Wait, it doesn't have to, but it doesn't have to be like perfectly accurate to scale or anything. It has to be.
Just like what's happening, right? That's a good question. All right, part D. When the height of the projectile is 100 feet above the water, how far is it from the cliff?
Oh, you go 200 to Y.
Nice. Y equals. Okay. And what do we do?
You put in
150. Wait, I don't know.
Wait, you said right, 100 or 200.
Yeah, I would say
Yeah, you subtract 100.
exactly.
Oh, it's
Exactly.
100, not 150.
Do you see that? So look at the equation.
Is that
It's
for
H.
D?
Say again
Is that
for D.
I just
Exactly.
put 100 in the second one,
Yeah, that's what I was
and
gonna
then just put intersect on.
That's perfect. You could do that way too. Absolutely, that'd be perfect. You could also, because this is like the height, h of x, you see the equation, h of x is equal to this mess. So this is like 100, right, which is the height of it. If I put 100 equal to this, then I could just subtract it to both sides. And then over, once I subtract by 100, what does that equal there?
100.
There you are. So once I graph it, now you'll see that it's kind of smushed down a little bit. So what would I be solving for here?
Maximum?
It'd actually be the zero still.
The zero of the exponent.
Exactly.
Just kidding.
So you could just go to second trace again, except now we'll go 0, left bound, right bound, and guess. And there you are, 19.31.
So hypothetically speaking, if this problem, a problem like this was on the exam, would A, B, C, and D all be the same order as they are here? Hypothetically speaking.
I'm good with that.
Thank you.
That's a great answer.
Good with that. All right, does that make sense?
Yeah.
What we're doing?
Can
Cool.
you go over long division?
Oh my gosh.
Because I've never understood that.
Also, after that,
I can
number
synthetically
two.
divide like
Number
for
2?
days.
How
Well,
about
that's
this?
synthetic, but I just don't know how to do it with.
And number 4, I have no idea how to do number 4.
Can we do some unit 4?
Yes, we
Can we
can.
do the entire test?
So cool.
Sure.
Should I just give you the exam?
Yeah.
Yes.
Yeah, but it's like a group exam.
Oh, is that what
I
it
can
is?
decide with that.
question,
Yellow working hard. Come on.
Unit 4.
or we could all just exempt.
Is that what we should do?
Yes.
We should protest.
Exempt for effort.
Protest? I like
E for
protest.
effort. T for effort.
Can I join the protest?
Yes.
Is that okay?
What if I go
Yeah.
straight?
You did great on
Oh, is that what someone told me that the other day? They were like, if you exempt me, that's one less that you have to grade. I'm like,
Exactly.
It's true. It's a win-win.
it's a win-win-win. I like it. Okay, I'm gonna do this. I heard a couple of them, and I want to get to those. I want to start with the division. So let's do synthetic and long division. Is that cool? And then we'll go to the other ones as well. Someone said number 4. Someone said, well, a lot of them there. So we'll go through those.
Wait, so where?
Unit 1 on the front page there. I don't want this right here.
Oh, we're number 6.
Number 6 too. Let's do this one. Okay.
Are we doing the long division or synthetic first?
Do you want to do number 2 and then we'll use that to go into long division? Okay with that? Did I mess it up?
No, I've just never learned how to long divide. We learned this in January.
Yeah, I know how to do synthetic. I have
Well,
no
we
idea
also
how to do
learned
more
left.
division. I just like stumbled my way through it. And was like, okay, I'm gonna get this
All
wrong.
right. Well, then we're gonna learn then.
All
We're gonna
right.
learn. All right. So divide by using synthetic. Well, first off, I think okay. So correct me if I'm wrong. Is the fraction the part that's throwing you off?
Yes.
Is synthetic? Are we okay with
Yeah.
synthetic?
Yeah.
Okay. All right. So let's just. I'm gonna go through this quickly on the process of synthetic. I mean, I feel good on. Again, I think it's more or less just the fraction that's there. Well, we know that over here, when we plug these values in, we know that we start with 2, the coefficient, right? And we've got to do what with the coefficients that are here?
Right.
Yeah.
There we go.
Got it, girl.
Great job.
So we got 2. What's the next one?
Negative 17.
There you go. 56 and
Negative 65.
negative 65. Good.
So
If I miss one, if
You
I
would
miss
have
a
to
variable,
replace older zero.
correct. Good. And you'll see one in a second where it actually comes in.
That's
Go
what
ahead.
I got there.
I like it. So what's in here?
Is it positive?
Positive 5 over 2. If it's a 0, so you have to.
Money.
So you bring the 2 down,
Good. Yeah. So we'll bring the 2 down.
and then you multiply by 5 and divide by 2.
What?
Correct.
Right.
Right. That's exactly right. So
Okay.
here's what I would say with this. If this was a calculator problem, right, I'd put this in as 2.5 and just simply in my calculator, 2.5 times 2, and you'd be okay, right? If this was one where you have to show work on, I would just off to the side say 5/2 times 2 over 1. Oh, what can I do with 2's?
Cancel.
Cancels, which would be 5, or Scott's method would work too. So we put 5 here. What would be the total on this one? -12, good. So then I would off to the side do 5/2 times -12 over 1. So 2 goes into -12 how many times? Good. -6 times 5 is? -30, good. What would be the next thing? Good, we got 26. And so we just do the same thing. 5/2 times 26 over 1. 2 goes into 26 how many times?
13.
And 13 times 5 is? 65. Good. That would be 0. And there you go. Now, big idea here. Big idea. What does this say about, now it doesn't say to keep going, and I don't have to. But because this is a remainder of 0, what does that tell me?
It's like 2x squared minus 12x plus 26.
Good. With no remainder. What does that tell me about 5/2?
It's a 0.
Correct. Kendall, there you go. Look at you. So 5/2 is a 0 because the remainder is 0, right? So technically, could I keep factoring this and like solving for the other zeros?
Yeah.
If I want, we could right now, but we're not
We
going
got
to.
other stuff to cover.
We got lots
We
to
got
do.
other stuff
For
to
this
cover.
one though, do you see how on this one, I can just stop because it just tells me to divide and then that's it?
Yeah.
So my answer would be this once I divide it. Okay? Cool. And then that's how I would do that number 2. How do we feel on number, well, let me go to the other division one and we'll go here. Number 6.
This is
Can
where
you
everything
explain
goes
why you do
horribly
the 0
wrong.
x?
Where I died.
So when you set up the division problem, put all like under the thing, and why is it x squared plus 0x plus 4?
Oh, good question. Good question.
I get
So
that, I just-
on this one, let me make sure I emphasize this. This is a really, really good point. X squared plus 4, I can use synthetic division for every division problem possible, except when I have something that's being divided by an x squared. Because if I said, what can I plug in for that to make that equal to 0? I can't, right? So on this one, when I said divide by using long division, I'm not trying to like make your life miserable, okay? Technically, I'm doing it because you have to use long division for this, okay? And then, so I'm trying to help you on that. So when I divide, I'm going to have an x squared plus, and Scott's right, because of the plus 4, I want to make sure I have a placeholder in for that. Now, technically, I've seen it done without, and that's okay. I think it's much easier if you just put the plus 0x plus 4 to hold that place value. That's there. Same holds true on the inside. You'll notice this one doesn't need 1, but if it was a 4 and then a 2, 1, and then just coefficient, you would say a 0 for that x to the 3rd, okay? But it doesn't, so we're just going to put x to the 4th minus 5x to the 3rd plus 8x squared minus 20x plus 16. Okay? Is everyone good with the setup?
Yeah.
We're good? Okay, so the question every time is the same. It's the same pattern. What times my outside number equals my first value? Let me say that again. X squared, right? What times my x squared would equal x to the 4th? And y'all are right, the x squared.
So it goes over the x squared.
I do. Others, some people will keep them here. I like everything to line up because it just helps simplify a little bit, right?
But okay, so you always take the first number on the outside, and what times that equals the first number, or what times? Yes, what times that equals the first number.
Correct. And then what do I do with x squared?
We multiply those and those.
Good, it goes to both, right? So what's x squared times x squared?
X to the 4th.
It's the 4th, good.
0 x 3rd.
Good, and that's why, Scott, I have to have that 0. Because if I didn't, A lot of times people will mess that up.
Okay.
Okay? So you must, even though it's 0x times x squared, you must put 0x to the third there. Alex?
X squared equals x to the fourth.
So this x squared, once I put it up here, okay, I distribute to each of these three. Cool? It should every single time. If it does not, you messed it up somehow. But the first value must be the same thing. Okay? Must be the same thing. So what do I do next? I'm missing one thing.
Oh, you have to switch the
Multiply by
signs. Oh, never mind.
That's true. Kendall, you're right. There's really two things I messed up or missed right here. X squared times 4 is 4x squared. And then Kendall, you were right. We're going to then switch each of these signs. Okay? Now let me say this again because it's the same pattern each time. What times the outside equals the first number? We got x squared. We distribute out, get it underneath, and then we switch the signs. Okay? If you do those three patterns every single time, you'll get it right. Okay? You will get it right. Because then once I do this, we can just simplify. And what happens with x to the fourth? Those cancel. What happens to the simplified version?
Negative 5x
Yep, and
4x squared.
4x squared.
minus
You
20.
repeat the process.
And we repeat it by bringing down just one value. Because I need 3 because there's 3 over here.
So
Okay.
the next one. Just
So now what am I focused on? What times x squared equals?
5x.
Negative 5x to the third. See the pattern? Same thing? So what times x squared gets me negative 5x to the third?
Negative 5x.
Negative 5x. Good. And then what do I do with negative 5x?
Multiply it out 3.
Yep, 3 times, right? Which would be what? Negative 5x to the third. Good. Would be the second one.
Negative 5x squared.
Just
Negative
Wait,
0.
no,
Zero.
negative 0x squared. sorry.
0x. Good. And then 4 times negative 5x is?
Negative 20x.
Negative 20x. Good.
Signs.
Switch the signs. Good. This cancels, right? Should every time.
Front and back cancel.
And then what happened? And then the back cancels too, doesn't it? So, but this doesn't. So what is this?
4.
4x squared. What is this?
0x.
0x. We still want to hold that spot, right? Because there's a value in front of it. So just hold it. And then what do I bring down? 16. Bless you. There you are. So we do the same thing, right? What times x squared gets me? 4x squared, which would be? 4. Good. And now we do the same thing, right? 4 times x squared is?
4x squared.
4x squared. Nice. 4 times 0x is?
0.
And 4 times 4 is 16. What do I do to finalize it?
Switch sides.
Switch the signs. Switch the signs. I get a remainder of 0. And if you did have a remainder, does everyone know how to write a remainder?
You have a plus, and then you
R
put it
to it.
over what you divided it by.
You could do that as well. Absolutely. I'll take either on those. So if it's a remainder, just put R whatever it is. Or you could put that remainder over like what Kendall said, this over here, x squared plus 4. But there's not. So you would just say, that's the answer.
You don't need to factor that out or anything.
No, you don't, but could you?
Yeah.
Why? Good, because there's no remainder, right? No remainder. Good.
Could we do one more of those?
Yes. Trying to see.
I don't know if there's another one on the actual review.
Do you want me to give you one to just try?
Yeah.
Is that cool?
Just remember.
Is it cool if I erase this? Is everyone
Yeah.
good with it? All right, let's do. Trying to see what I can. Let's do that one. Let's go. Give you a little bit of a curveball.
Do we have to turn this in?
No,
Can we
actually.
for bonus?
Can we
Please
promote
God.
it?
Yeah, can we just-
No, well, because I've already got. I'm hearing you. I've already got it built in already.
Okay.
That
Oh.
what's in there already. There's already bonus inside there. So. For
Thank
challenge.
you.
Well, this
I'm gonna turn it into
It's fair. I respect that. Parker, do you want me to go through this, or did you want to?
Yeah, can you just go through it? I think
Okay.
I got it, but I just want to do it.
Could I check it real quick?
Sure.
Have you just started there?
Yeah, I just started it.
Okay. How about this? I'll check on the setup, and then I'll check to make sure the end's right. Is that cool? We'll see. So what'd you put on the outside?
X squared minus
One thing missing.
plus 2.
That's -2. You're right. Just put that plus 0x in there to help yourself out.
Gosh dang it. Okay, see? Already messed up.
You're good. And what goes on the inside?
2x cubed minus 0x squared.
I'm good with that. Yeah. And then what?
0x squared. And then minus 8x plus 4.
Good. Good. Do this. Get me started just at the first part. What's the question we're asking?
What times the first number equal on the outside equals the first number on the
Nice. Nice.
Coach. You do to me.
inside?
You're right. Yeah, exactly. Good. Keep going. Let's see if you got it. Let's see if you got it there.
Okay, so, and then so 2x times x squared equals 2x cubed,
Good.
And 2x times 0x is 0x squared.
Nice.
And then times -2 is -4x.
Yes. Was that the one we were going to?
It's the one about John Deere.
Are we good on that, y'all? By doing that, I know a lot of people said some stuff. Jacob, did we? I think you said 6, right?
Yeah, we got it.
Got that? Man, we're getting this done, y'all. You know? Do we feel better?
Actually, I wanted to know, out of my 3 exams, this is the only one I'm actually gonna study for.
I have 4.
I respect that.
Like, I have.
This is the only one I did not
I'm coming to these.
I'm not studying for this, I'm not studying for the Bible, I'm not studying for taking macro.
I feel honored, y'all. I really do. I feel really honored.
I feel like this one's mine.
No, I could do more in Bible, I just didn't want to give Townsend the
Those Bible exams are hard.
I don't care. It doesn't matter if it's hard or if it's easy, I'm not gonna study for it. Wait, can we leave when we're done with our exam?
Yeah.
Wait, really?
When
Say that again.
When is our exam?
Like, if we like fill it out and like,
The
we have,
exam
like, an hour
is
left.
Wednesday.
Coach, if we're taking an exam and we're like finish it, so do we have like an hour left in the period, can we leave?
I don't think so.
Alright, cool. Great.
Plans?
No, I just don't want, I don't want, I'm making a fellow in the Bible.
Okay. Hey, let's look at this
I
one
will
because
take a nap.
Dory's right. This one is a little bit tricky. On this one, this is number 4. So really quick, this is when we plug it in our calculator. I literally that's all I did was plug it in. But it says something else. It says what unit price would be associated with a revenue of 200,100. Okay, possible. I mean, one similar to this. in
It's
terms
not
of-
highlighted, I'm just saying.
I'm just saying.
Still
Which one is
mine.
this?
Still mine.
Number 4.
So what would I put 200,100 in for? R of P, right? Does that make sense? Because it's a revenue, right?
So,
So once we go ahead and park.
just now the whole thing equals 200,100, and then you just simplify for p.
We can't divide by p because there's a p squared. If there was, you're right. If there was just one p, you'd be fine. But the p squared throws us off a little bit. So do you see how, like, if we set this equal to 0, Parker, what would I do to get this equal to 0?
Subtract 200,100.
Correct. That makes sense? So we could just take this and then just include what at the end of it? That's exactly right. Scott?
Was this the thing we did the project on? When we had to make our own little company?
Yes.
Similar.
That's why I don't remember this.
Yeah, don't worry.
What does that mean?
Cheers. This was January, wasn't it?
Yes.
Yes.
That month is a whole.
So
What happened?
is everyone good? Here's the thing. On number 4, are y'all good with getting it here?
No. Jay, I have this exam and then I have 8 macros directly after it. It's gonna be a long day.
Sorry. But then you're done.
No, I have Bible, which I'm gonna say. I'm gonna see how low the score I can get on my Bible. I'm gonna see it. I'm gonna get the lowest possible score.
All right, here we
on my
go.
Bible.
Let's keep it going. Alex, you good over there?
I'm gonna get a
Oh, the
13.
200,100?
Where's?
Alex, are you good on that?
Write my name.
Good. So here's the deal. I'm plugging this in, and when it says unit price, you'll see that instead of P, I put X, okay? Because, again, it's on a calculator here. But I'm trying to solve for what X is, okay? That's literally it. I'm trying to solve what X is equal to by using my calculator. So similar to what I did last time, I'm going to go to my graph. And when I do that, you may or may not see anything. And you might see something that looks like this. Okay? Not very much, right? If you saw nothing, which is possible, you could go to Zoom Fit and try to go through it that way. Another thing, too, is we remember that if all I saw was this line, we remember that you could go to Zoom what? Go to Zoom Standard. You could also zoom out, right? So when you zoom out, you can go over yonder. Right here. There it goes again. It's a mess right here. Just a line going up. Go up, 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 up. I'm just trying to get this in my window. So I'm going to zoom out again. Oh, there's one line.
Yeah.
Oh, it's exciting. One more time. Oh, look, there's two lines.
Wow, we did it.
Well, kind of.
Wait.
Kind of.
He's about to be like, wait, no.
So basically, this parabola is going up because it's negative, right? So you could, it's going downward. So it's going up and then hitting and then coming back down again. Y'all follow me on that?
Yes.
Okay. Now, on this specific one, it talks about a tractor, right? Like the unit price of a tractor. And so technically, well, I'll tell you, it could be either one of these values because it doesn't say what type of unit price it could be. So it could be, all we're trying to do is see where it hits the x-axis, right? Scott?
So it has 2.
Could have 2 possibilities. The reason why is when you talk about a tractor, this one, and I'll show you in a second, but this x-intercept is like $130, and this one's like $3,000. Now, which would be more realistic? 3,000, but someone,
Toy tractor.
it could be, yes. Someone said it was my tractor. If you want to do that and fail, then that's fine. Yeah, you could get that. But I'll actually take either answer. Kendall?
Okay, how do I make mine look like that?
Okay, what'd you start with on the Zoom function?
It looks like, zoom out until you're out of the classroom.
That's an issue.
Did you start with Zoom Standard?
Yes, and then I did Zoom Fit. It looks like a diagonal line.
It does?
So I might have put something in wrong.
Go to Zoom. Yes, what's up, Rita? You can, yeah, come on. This is pre-Cal 12, so you're good. Y'all can come and hang. It's Chrissy. Okay. Would you mind just telling him he could come in for me? Thank you, Rita. Oh, is this it?
Yes.
I don't know what to do from there. Nah, I'm just messing. I would do this. I would zoom out. I would go to zoom out here and just when I go, just go. We want to try to get up in that top right section. What's up, Chris? Man.
So,
Yeah, I got $108.
you don't get it, that makes sense.
What?
And so I'm just trying to zoom out right here. And I'm just going to keep zooming out
Okay.
until I try to hit that spot right here. Now, again, what I'm trying to do, Kendall, is I'm trying to find what that is, right? When it hits the x-axis.
Okay.
So wherever I'm at, whatever my picture looks like, I just want to make sure that that's in my window. So then I want to find that by going to second trace, go down to 0, and go left bound, which is to the left of this. Right bound, I want to make sure I'm above that, right? So I'm going to make sure I go to the right here.
Oh, I'm looking for the first one? You said it doesn't matter.
Does not matter for this context.
What's this question asking?
It asks, what is the unit price of the John Deere tractor with the following equation?
Okay.
Okay.
So,
You follow me?
yes, but if there, I don't understand, like, just, I guess this doesn't matter, but if there's a unit price, then why is it parallel? Like, I don't, like, why is there two X?
So within, when you talk about like supply and demand, like you've heard of supply and demand, but usually it's linear, right? You have a supply and a demand curve, right? Well, within this, what they've said is that the equation of -1/2 p squared plus 1900 p, that follows a revenue curve for the tractor of a John Deere tractor that's there. Does that make sense? So when the R of P, which is our revenue, is 200, if we want that to be 200,100, we can plug that in for Y, subtract it, and then once we do, we find what the 0 is. And in this case, if it's Coach Jay's tractor, it'd be $108. If you did the other side, right, that'd be a normal tractor, yes.
Why did the graph change? Like, why did it go from 2 lines or parabola to there?
It was all my perspective. So I could have done this. I was just trying to help Kendall out with hers. Yours could look different depending upon how I zoom in and out, right?
Oh, okay.
So it's like if I looked at this, right, and I went like, I looked at just this piece, that'd be much different than if I like backed up, right? And then focused in differently. So basically it's the same graph. All I did was instead of focusing really far back and seeing 2 lines, now I focused on just the section that's closer to the origin.
It's gonna give you the same thing.
It will.
It's just.
As long as you plug it in right,
Yeah.
you'll be fine. You'll be fine. I just wanted to help Kendall out because that's where she was.
Yeah.
Sweet balls.
Can we do number 3?
Number 3. Let's keep rolling. Let's do it. All right, number 3 is it's kind of going backwards from what we were talking about earlier, where it gives me what the degrees of a polynomial is. Let's see here. I want to make sure I'm. All right, still there. Okay. Okay, so on 3, it says we have a degree of 4 polynomial, okay? The zeros are -3, 0, and 2 with a multiplicity of 2, right? So what do I do on this to be able to get it in standard form?
Should you just,
Number
like,
3, unit 1.
do them all? Like,
You
X
just do
plus 3?
And then you go to find out.
That's it. So since we have 4, what I would do is just put 4 of them. And I think, Chris, you were saying that. Kendall, you were saying that too. Literally plugging them in, and then we'll just distribute that out. So what would -3 represent?
X plus 3.
That's it, X plus 3. And then 0 would be
An X.
an X, good. And 2 with the multiplicity of 2, what does that mean?
X minus 2.
Just means there's 2 of them, good. And so what I think it might be easier to attack this by going these first 2 and the last 2. So what's X times X plus 3 equals?
X squared plus 3X.
Good. And what's this X minus 2 times X minus 2?
X squared plus 4. Or X plus 2.
Minus 2X, and then the plus 4, right? Just be careful on that to make sure you distribute to each one, right?
So it's minus 4X.
Correct. X squared, so we have X squared minus 4X plus 4 and x squared plus 3x. I don't think this is hard. I just think it's tedious.
Yeah.
Just there's a lot of ways to mess this up. So just make sure, take it step by step, because if you mess up one little thing, it can throw it off there. So like x squared, what I do, maybe it helps, maybe it doesn't. I just take the first one and then just distribute to each of those 3. So like x squared times x squared is the 4th. X squared times negative 4x is negative 4x third. X squared times 4 is good. And then I do the 3x. So 3x times each of these.
Third, negative 12x squared. 12x.
And then negative 12x. Good. Or positive 12x, sorry. Good.
Add like terms.
Add like terms, we can do that. So we've got x to the 4th. What about to the 3rd? What would that be?
Negative x.
Minus x to the 3rd. I just kind of cancel them out. And then x squared.
Negative 8x squared.
Good. And then what about x? 12x. Good. So that right there would be my polynomial distributor.
That's not
Okay.
Do we do number 7?
Yes, good idea.
Gotcha. Scoop.
Oh, boy.
I like it. All right, number 7. Let's go there. Same thing. On this one, it's more just the tediousness of just going from one to the next, right? So if I've got 3 things here, I would distribute the negative I to the 1 minus 3i first, okay? So if I did that, what would that turn into?
plus 3. It'd be minus 3, right?
Plus 3i squared, which if you can make that jump, that's perfect. Because what's plus 3i squared turn into?
Minus 3.
Minus 3, good. So we have negative I minus 3. And now I'm going to multiply by this second one, which is what?
4 minus 6i.
Good. Okay. Questions on that?
Is it not plus 3?
Because I squared is negative 1 and negative 1 times 3.
But, oh, I thought it was, there's a minus 3.
Where was that again?
Oh, you're right. She's right.
Well, then you multiply the negative I and negative 5, and it makes plus 3x squared. And then you do the
Oh,
I
yeah,
squared,
yeah.
and then it makes negative.
Because it's negative I, and negative I times negative 3
So it's
is positive.
oh, so
I
it's
squared.
plus 3. Okay.
Does that make sense?
But then the negative.
And then for the square root of negative 36, the square root of negative 36 is 6i. They put the negative or the minus beside it. It's 4 minus.
Yep, and that's how I got it. Does that make sense?
Yeah.
So then we just go step by step again. Negative I times 4 gets me. Negative 4i. Negative I times negative 6i is
6i squared.
4 gets times negative 6i is
Plus 18i.
plus 18i.
So it would be minus
So it's
6.
negative 18 minus 18i.
Yeah, put positive 18i minus 4i, which is 14i. And then what does 6i squared turn into?
Negative 6.
We have negative 6 minus 12, which is negative 18. So negative 18 plus 14i. That's what I get there.
Good stuff.
8 would be the same,
Yeah.
wouldn't it? Just be sure that once I do it, 3 minus 2i, just square it, right?
When I did
Me too.
number 7, I did 1 minus 3i and then 4 minus square root of negative 36. Like I boiled those first and I distributed the I and I got the same thing. So like that.
Yes, so that's perfect. So if you do these 2 first and then do the negative I,
Yeah. Okay.
perfect.
So I got the same.
Good. You have a question?
Good.
Can you do number 9?
Number 9 on there?
Yes.
Yeah. Let's go.
And 10. I don't know.
9 and 10?
Yes.
Okay, 10's like a quick one. Cool.
Goes down.
So we know that like 2 things we look for.
The problem.
Goes down.
What's the highest exponent?
Yeah.
6. Circle the number with that, and that's all we're focused on when we talk about end behavior. Okay?
So it opens downward.
It's negative, therefore it could possibly open downward, maybe. We know that it depends upon, is it even? If it's even, it goes together, right? So think even, smiley face, like if you're positive, they both go up, right? Rise right, rise left. If it's negative, it goes both down. If it's positive, odd, and negative odd.
Wait, whoa,
Right.
hold on.
I think this is
On
the formula.
formula
You might
sheet.
also-
Oh, it is? Oh, okay. Oh, okay.
You're chipping a little bit.
Never mind, I don't have.
Yeah, it goes positive even, negative even, positive odd, negative odd.
So,
I don't know.
wait,
That's right.
the coefficient or the exponent?
So the exponent tells me, okay, so this 3 means nothing.
Cool,
Only whether it's positive or negative does that tell me anything.
okay.
The 6 tells me that they will both go together.
So, okay, so it's nice, so it goes down.
Perfect. So it's going to go together. It's negative, therefore that's a negative percent. Both will go down, fall to the left, and fall to the right.
Got it.
Sit. That's all we got.
And then number 9.
Oh yeah, number 9. X-intercept and Y-intercept. X-intercept we plug 0 in for
Why?
Y.
This is not.
For Y. And Y-intercept 0 for X, right? Okay. So let's try this out. X-intercept 0 in for Y. So Y would be here. So we would say 0 is equal to -4 times x plus 3 squared plus 5. So solve for x. How would I do that?
Distribute negative. Well, FOIL. Wait.
You could foil this, absolutely. I think what makes this maybe a little easier is just get x by itself by subtracting 5. Okay. So subtract 5. Just keep getting x by itself, however you can do that. So what would I do next?
Divide by 4.
Divide by -4. Good. So we got 5 over 4 equals x plus 3 squared. What do I do next?
X squared plus 9.
Now you.
No, wait, that's so wrong.
I can't.
Don't listen to me.
No, you're good. Remember, if I have x plus 3 squared, that would mean I would have to FOIL each of these, right?
Yep.
Not just the first and the last.
You're right, I just looked at them.
You're good. Is there any way I could get rid of that squared to be a little bit easier?
Oh, square root both sides.
Yeah. So if I square root both sides, can I evenly square root 5? No. Can I evenly square root 4?
Yes.
Yes, I can. So I would say that this would be the square root of 5 over 2 equals x plus 3. But if I square root of squared, what happens to the other side?
Plus or minus?
Good, Ken, very good. So plus or minus square root of 5 over 2,
Minus 3.
and then just subtract 3 on both sides. Get -3 plus or minus square root of 5 over 2.
That was not.
Did I throw you for a loop there? Where did I throw you?
No, I got it. It's just like not at all what I had written down. That's good.
You said it right. You said it right. Did you put -3 on this back side?
Some of them is just a matter of like what to do.
So this is x-intercept.
Correct.
I got it.
What if I said find the x-intercept and I had something that looked like this?
You just factor.
You could factor. Good. Or quadratic formula. Yep. But same idea, right? X-intercept, plug 0 in for y, and then solve. Right? Y-intercept is much easier. Because what?
0 in for x.
Just 0 in for x, right? So we would say 0 goes in for x. So -4 times 0 plus 3 squared plus 5. Well, what's 0 plus 3?
3.
Squared, we get 9, right? So then we have 9 times -4, which is?
What's going on right now?
-36.
We're doing the y-intercept, where we plug 0 in for x. So right here, when I plug that 0 in for x, that's where I would get 0 plus 3 squared to get 9 times -4, which is -36, and then plus 5, which would be
Negative 31.
31. Good. Okay.
And then that's it for that.
Because I'm always tired after lunch.
That's it for that.
That'd be it.
Okay.
So it's, just make sure you label which one's which too. Okay.
Well, would X equal, would X equal Y equal
Double
B?
up, Randy, so.
I would say you can just put like this is the y-intercept. This is the x-intercept.
Okay. Thank you.
You're welcome. I guess x equals and y equals. I could take that. All right, Michaela, what are you thinking? We okay on that one?
Yeah, so I'm pretty, we just have to,
Gotcha. Alex, what you thinking?
not give it.
You good on this one?
Yeah.
Unit 3?
See.
Okay, before I move to the next unit, and I'm good with that, I want to just make sure. Unit 5 we've done completely, right? Rita and Chris, if y'all, I know y'all just came in, we're gonna have time too as we go through this week. But I'm also podcasting these as well. Okay. We've done Unit 1, right?
Yes.
And we've done Unit 5. Alex is saying Unit 3. Are we good with Unit 3?
Unit 2 isn't that bad.
Everything.
Oh,
Okay.
We still in unit.
no, I guess.
This is unit 2.
Oh, yeah, I did.
Yes.
Amen.
Once I have those, then I can plug them into the synthetic, because once you know
I have to get a 60.
correct, and you can simplify it. That makes sense.
What do you?
All right, I'm gonna be right back, and then we'll do Unit 3 for Alex. Cool. We gotta get some.
A 70.
My eyes, my ears are wide open, ready to listen.
Come here.
Come here, Chris. Oh, yeah.
You just put the numbers in. Per P E R T.
Lars, you put it in here. Why are you going Y equals? It's not a graph, Lars. Where did you put it, dude? Right here. This is the formula, box.
Wait, Commissioner. Do we have our formula sheets before we go into the final?
No, ma'am, like, you can't write on them, but you can look at, like, what it would be on there, for sure.
Okay.
Um,
So like, you can't write the stuff where, you know, like with the last year we did, how everything was like a little tricky with like which way, like you let us write on our last one, so we can't write on this one.
Can't write on there, but you can look and see what's on there,
Okay.
and especially, it might be good just to know where everything is,
Yes.
so, for sure.
Okay,
Um,
thank you.
Let me see if I've got it.
Okay.
Cool. And that way, maybe I could pass it around for you to write on there. And I haven't forgotten about Alex. I'm coming in at 3, right?
Oh.
Cool. How about I put that on online? Is that cool?
Yes, sir, that works, thank
I'll
you.
put it right on the front of the test review or the exam review.
Okay, thank you.
Put it right at that very top.
Oh, it's like you could sit here.
Yeah, you just do it.
Well, wait, because it's
Negative
one
one
square.
Second. Second.
Okay, y'all ready? Y'all ready?
Yeah.
Christian, how we doing on this stuff?
I gotta do that next.
All right, Unit 3, Alex. We'll do that. Ken?
Before we go to Unit 3, I have another question on Unit 1.
Okay, come on.
Number 8.
Okay. Just how to approach that one.
Yeah, because the squared is really off.
So when you go to that one, what I would say is just simply do the, like, if I was doing this, 3 minus 2i. Times 3, does that make sense?
Yes.
The only thing along with that is just make sure the negative is distributed to whatever's being squared over here.
Okay.
Cool?
Okay.
And that would be the
Is
only
it okay for like number 8? What I did was, I did like 3 minus 2i, 3 minus 2i, and then I did 4 plus 3i, and 4 plus 3i, and then I put them together. Perfect. That's okay.
Good. Just be careful. Make sure the negative is distributed to whatever's on this right side.
Yeah.
Got me? If you did that, you got it. You're good. You're good to go. All right, Alex's unit. Here we go. This is for Alex right here. All for Alex. Right here. Sound good, Alex? Alex, I like that basketball shirt. Still waiting on a response of you playing. Okay. All right. Just a little salty. Alex was like one of our best players in 8th grade. This is on the podcast here.
Scott was the other one.
I remember I was in the 6th grade at John Street. And we came over to scrimmage GSC. I was yeah. Wrong sense.
Here's the thing, though. Here's the thing. Alex was a good player. He was a good player. Literally, this is what he told me. Last thing, Coach. I'm thinking. I go, Alex, are you gonna play next year? Coach, I'm playing next year. I'm so excited. I'm coaching on varsity too. So I'm interested. I'm hoping you'll keep playing. Literally, the next year doesn't show up for anything in the summer.
Right.
And I was like, Alex, where you been? Oh, I'm coming out next year. Never showed up. I'm still waiting on Alex. So I'm doing Unit 3. I don't know why, but I'm gonna help you out.
I'll just go through like all of them because
This one?
Yeah.
Okay.
logs are logs.
And we
Yeah,
still
I
have.
have never like
Yeah,
fully understood logs.
Okay.
Never.
Amen.
Side note.
What month was this unit?
Side note.
March.
March.
Oh,
That's
really?
All right. Let's pretend that this is 8 to the x power equals. This is a side note. Equals 1 over
4.
64. Okay. All right. 1 over 64. Now, if I were to approach this one, and I were to say, convert this,
Wait,
solve for
is
x
this just a hypothetical thing?
Mhm.
Oh, okay.
by doing a 1-to-1 equation. Okay.
So what did you? Oh, just kidding.
Either way, yeah.
You got it, Scott. It's all you.
Come on,
It's all
Scotty.
you.
All right.
Boots.
So I have a feeling that 8 is gonna move over to the right side, maybe?
Okay, so
Is that one of these?
You lost
It would
both
be
sides.
8, okay, so 64 is like the square root of 8. So wouldn't it be like 8 to the whatever?
To the 1.
correct. Yes. So
8 to the second, right?
Yeah.
No.
you're
Yeah,
correct.
right.
Close.
Yes.
So when I look at this, one thing that I gotta remember is I'm trying to solve for x. I can't get x by itself by dividing by 8.
Oh yeah, so then you
Does that make
you take
sense?
1 over 8 squared because 8 times 8 is 64, right?
Good. So this is, we're trying to get it to where they have the same basis. Alex,
Log both sides.
you could absolutely do that. Okay? Absolutely. I'm trying to show you how there's another way as well. Okay? All right?
So okay, I got this
I have
good.
a quick.
So it's 1 over 8 squared,
Okay?
and then you still have equals 8x, and then the 8's cancel out.
Is it just 2?
So then you're left with x equals 1/2, right? No,
It's 8.
I'm lying.
X is
I was
-2,
joking.
right?
That's
Correct. So here, let's do this. Let me back up and make sure I talk through this one because this one's weird. When I get here, 1-to-1 means we want the same basis. Okay? So 8 to the x stays on the left side. On the right side, 8 squared, we want to move to the top.
Oh, so it's
So we make it 8 to the negative second
so
power.
then the 8's cancel out.
8's
Then you're
cancel.
left with x equals 8.
Good. Okay, absolutely.
Well, wouldn't you just kind of know from 8x over 1/64 that it's gonna be -2 because 8 to the second is 64 and it's under 1, so it's gonna be negative?
You could. You absolutely could. Here's what I would say, just be careful on, is what if I said x plus 1 here?
Oh, that's
And you would do the same thing. You would just, once you got it here, you would set x plus 1 equal to
Negative.
-2.
right. Okay.
Follow me? So that's fine. If you can visualize it, go ahead. But I just want you to know the process.
Yeah. Okay.
Okay? Now, what Alex said was completely true. Okay? You could do that. But that comes into number 1 where 3 and 5, it's impossible to get that to where the bases are the same. Okay? So that's where logs come in. When we can't get the bases to where they're the same, we log both sides to simplify. Okay? So it'll look like this. If I log both sides that have log of 3, the 5x plus 1, equals log of 5.
You gotta take the log there on the other side.
Good. Take it to the right side. I like that. One step right before that, Trey. And you mentally might have done it, which is perfect.
I'll bring the fathers now.
The 5x plus 1 is an exponent that's got to get shot to the front. So this gets shot to the front. Good. So I have 5x plus 1 log 3 times log 3 equals log of 5, right? So now, can I get rid of that log 3? By doing what? By dividing log of 3 to both sides. So I'm going to take log of 5, divide that by log of 3. And then that's how I get z equal to 5x plus 1. Kendall.
I don't know what just happened.
Yeah, wait, what's the final answer?
So we're not quite there yet because we want to take this in our calculator. Are you stuck here, Kendall?
I'm like at the beginning. Like, how did you do the 3? Make the 3 go? Are
So,
we doing number 1? Yeah. Okay.
so you know I logged both sides. Are you good there?
You log both sides.
Mhm.
Is that just like a rule, or how? What? How do you do that?
Well, my first step is if I can get the bases to where they're the same, let's do that.
Okay.
But I can't because 3 and 5 have no way of being the same.
Okay.
So that's why I can do a log on both sides.
Okay.
And then once I do that, this exponent, by our exponent rule, which you'll have those rules there, can be shot to the front of that log, making it 5x plus 1 times the log of 3.
And you do that for both sides? Like log, you have to do log 5 if you want.
Correct. Exactly. So then once I get to this on my right side of log of 5 is equal to this, I can divide by log of 3 on both sides, right? By doing then log of 5, you can just go log of 5, I press enter there, and then I just simply divide that by the log of 3. And that's how I get to that value, okay?
And that, so can you round then to just like 1.5 equals 5x plus 1?
I would just keep it to 2 decimal places, 1.46,
Okay.
but that would work.
So why didn't you do the exponential? Where you like bring 3 or you know what I'm saying? Why don't you bring 3 to the other side and do like log base 3, 5, and then have the 5x plus 1?
I could do that. I could. That's the same thing.
Okay.
Because if I did that, I'd have on the right side log base 3 of 5. Follow me? Which when I put in my calculator, guess what that would be in my calculator?
Same thing.
Log of 5 divided by log of 3. Does that make sense?
Oh yeah, because you do the change.
So how do you
Bingo, that's impressive.
know, like, what I'm confused, like, that's, I get that, but I don't get when to use log, when to use e, when to use ln, like, I don't understand that.
I think we just, as we go through processes of just dissecting, oh, this is how I would attack this, right? I think that would be it. So like the first one, 1-to-1, try to get the bases to where they're the same. So right now I've given you an exponential equation. Try to get the bases to where they're the same. Check 1. Check 2. Try to get the bases to where they're the same where we can't. So we log both sides, right? So then once we log both sides, we're trying to solve for x.
Right.
So we then simply go step by step through it to where now we can subtract by 1 and then divide by 5, right? So once I subtract by 1, which is here, subtract by 1, and divide by 5. Exactly. So 0.093. So we would just say x is equal to 0.093. And that right there would be my x value.
Right. Okay. Yeah, that's not hard to me. It's just when I don't know where to start.
Gotcha. So I would just say at this point, as we go through, it's all about the processes of, okay, we got exponential. What do I do when I get an exponential? Check that one off. We got that one. Now let's go through some other ones. Let's just make sure we're getting them as we go. Are we good up through these two, though?
Yeah.
We're good up through those two? 4? I'm good with that. Number 4. Okay, so this is another good one. Okay. We understand that the kryptonite of ln is E, right? ln and E are like kryptonite.
Is the x plus 1, is that in the exponent? It's kind of hard to tell.
It should say this E to the power of 2 ln of x plus 1.
Oh, okay.
Cool. Now, E and ln can cancel. They absolutely can. However, they can't right now because there's a 2 in front.
You have to take that.
Yeah, what does that mean? What rule do we have if the 2's in front? How can I get rid of that 2 in front?
Can't you put it to x plus 1 squared?
Put it to the exponent, right? Right? Do you remember that? Because we just had done one similar. So now what we have is E to the power of ln of x plus 1 squared. Can I cancel now?
Yes.
Yes. So now this cancels, leaving me with x plus 1 squared as my answer.
So that's your answer, right?
So
Do you want us to simplify that out or just leave it?
that's perfect like it is. It's good.
Is that rule on our formula sheet? Are these rules on there?
This is more of a process, the E and ln thing.
Okay.
The rules of the power,
Yeah, I'm
yes.
saying like the rule that like you can move the 2 to the,
Like the backside?
yeah.
Yes. Yes, that rule is on
We're
there.
moving that first. That's the first thing we do, is move the 2 to that side.
Correct. Because I can't cancel unless that E and ln are by themselves.
Is there a reason why you can move to the back?
Yeah, it's a rule. It's a property that we've got there, which I can get to number 6 and 7, which will utilize those rules that are there.
Can we do 3?
Yes, absolutely. Number 3. Okay, so similar. These are rules as well. We note that we have 2 logs on either side, but I can't cancel out the logs yet because on the left side we have 2 of them that are not together yet. But I can put them together. How can I put them together?
Wait, is the question mark supposed
You
to be
combine
there?
them because
No.
they are the same base, so you put log 7 minus x multiplied by 3x plus 5.
Good, Chris. Yeah, that's exactly right. So because of the plus, right?
Yeah, and then you can cross out the logs so you have the same base on each side. And then from there you just use like the regular equation.
You're right. That's exactly right. So first thing is this. Remember the power rule, right? Okay, we did that. Check that one off. There is no number in front of the log, so we can't have the power rule. But when I add 2 logs together and they have the same base, which is this 8 here, we can multiply them when we add those 2 together. So, and again, that's another rule I'll give to you as well. So I'm going to combine them together. And what we have now is just 1 log on either side. You see that?
So the log ain't won't affect the power after it's canceled, right?
Exactly. Once it's canceled, it's gone, right?
Then yeah, because they're both log 8, then it just goes away.
Yes. But just be careful. Make it 1 log before I cancel them out both sides.
Okay.
Okay?
Yeah.
Nicole, are you good on that? Gotcha. Is everyone good on that part? Alex, you good on that?
So then you're just left with like the factored out.
We gotta multiply that out.
Mm-hmm. Exactly right. Just got to multiply them out.
And then equals 24x.
Mm-hmm. So we would get 21x minus 3x squared plus 35. And then minus 5x equals 24x, right? And now you're just solving for x with an x squared, right? So because this is a negative 3x squared, let's move everything to the right side, okay? So we could just change the signs here. We know 21 minus 5 is 16. Good.
Can't you just have it maybe?
24 plus.
Say it again.
Why did you move? Can't it just be negative 3x squared?
You could. A lot of times it's a little easier when the x squared is positive. That's your call. You could leave that. So I'm just showing all the work here by now we're gonna add, subtract, just taking everything to the right side. So we got it here. 3x squared minus 16x minus 35. And so what do I have left over?
Negative, well, you moved it, but negative 3x squared minus 35 minus 8x.
Correct. Exactly right. And if we moved it to the right side, it would just be the change inside of 3x squared plus 8x minus 35. Right?
Wait. Plus 35, right?
Was it plus 35 on the left side?
I got minus 35 on the left. So.
No, it would be positive on the left.
On the left?
Yeah, so it would be negative.
Did you do 7 times 5 here?
Is it the same time tomorrow?
Same time tomorrow. Yes,
You
ma'am.
start at 9.
Sorry, that was me.
Yes, we'll start at 9.
I
My
thought it
apology.
I thought it started
No, you're
at 10.
I said 10, but I said if you wanted to come in earlier, you could.
Okay.
No pressure. I just put a little extra hour in.
Where's 16?
You're right, Coach. I got it. Thank you.
Say that again.
Where's 16 X come from?
16x here. That's when I distributed. I got 21x minus 5x here. Just when I distributed up here. And then once I combined them, that's where I got the positive 16x.
That's 5 times.
Does that make
Is
sense?
that my answer? Or do we have to simplify?
So yeah, from here you use quadratic. You can also factor. That's possible.
We can't leave it like
You can leave it like this. To get full
you're
credit.
solving correct. Sorry. Yeah.
You would get half credit at this point to get here, right? But I would just keep going, solve for x. So where you could factor this by what would each of these start with? We're trying to get here, right?
Oh, 3.
3x. Do y'all do 8 times c method or
No, I hate that. I
You hate that one?
Yeah.
guess and check? Is that what y'all use?
Yeah.
That good? Okay.
Cause like the 8 times C, I just always forget.
Fair. Fair.
Wait, where did 8x come from?
The 8x.
Thank you.
You're welcome. Have a good day. And then right here, Jacob, when I subtracted 16, I had a 24x on the right side. And so that's how I got that 8 there. So what 2 numbers multiply give me 35? 7 and 5. So we could just put a 7 here and a 5 here, right? One will be positive, one will be negative. Right? What's negative 5 times 3x? Negative 15x. And 7 times x is 7x. What's the difference? Negative 8, which I need positive 8, right? So that means these numbers are right. We just need to change the signs there. Does that make sense?
Yeah. So that's your answer. So well, it'd be negative 5 and 7.
Yep, so once I set these equal to 0, it would be x equals negative 5.
Yeah.
And what would be the other one? Would that 7 over 3, because I'd have to add 7 and then divide by 3. Say again? Ooh. Back up.
Okay, it's not that bad. I just always panic whenever I see vlogs. I panic. It just
I feel like I'm not gonna know what to do.
Yeah, thank you. Yeah, it's not too crazy. I will say this one makes it tougher because from the yellow part, what I have over here, you have to use either the quadratic or you can factor. The big thing is just setting up the process, right? That's the biggest thing. Process is the biggest thing as we go through. Well, here's the thing. As we go through any of these logs, are there any other ones that you say that you need some help on?
5.
5?
5.
Okay.
What is that?
Is that a log?
You find the vertical asymptote of a log. Or of an ln.
So it's a log, right? Does that make sense? Do we remember? Okay, so an exponential has a vertical or a horizontal asymptote, right? A log has a what type of asymptote? Vertical. Okay? So traditionally, a log, which is either an ln or log, right? This is just a common and a natural log. Both are the same types of graphs, right? The question that I have is, if I'm looking for the vertical asymptote, which is traditionally at 0, a vertical asymptote changes how? Left and right. Good. Good. So it changes based upon horizontal transformation, right? Right? So think about if I got a vertical asymptote, if I'm a vertical asymptote, and I change up and down, does that change me?
No.
It doesn't. But if I change myself left and right, that does, right? So what would that 3x minus 9 do to my graph?
Where did you go? To the right.
Close. I would set this equal to what? 0, right? So if I set 3x minus 9 equal to 0,
You'd go right 9, right?
close. Right 3, so
Right,
let's
you divide.
right 3. Good. So I'm going to add 9.
So you're here.
X equals 3. Jacob, you're exactly right. Good. So this is going to go from what 0 was. It's going to go right 3.
Oh, so our vertical asymptote is X.
Good.
Again,
Keep it
Wait.
alive.
So that's the vertical
Since last
asymptote.
week, no.
The vertical asymptote would be X.
So
Hey, it's
what's
No,
Let's go.
Ooh, man, that's tough. X-intercept. I plugged 0 in for it. Y. Good. So I would say 0 equals negative ln of 3x 9. Scott, how you doing, man?
Thank you.
You're welcome.
So say on the line.
Same time.
Sweet.
So how do I get x by itself? What do I do with the negative? I would get rid of it, right? Right? So this would be negative 0 would just be 0, right?
Yeah.
So I'd say 0 equals ln of 3x minus 9. Get rid of ln.
Just got rid of the
Negative.
yeah.
I could because negative 0 is just 0, right?
Okay.
If I do it to one side, I can do it to the other.
E.
E.
I don't know why, but you do.
Yep.
That's just how.
Because that's kryptonite, right? So e to the 0 power. Plug that in your calculator, but it's 1. Just because I want to get rid of that, but if I set 0 to it, get rid of that negative. Negative 0 is 0, right?
Oh, this is okay. You have 0 equals 3x.
No, 10 equals x. 10. 1.
Yeah, because the ln on the right side, what's the ln? E, right?
Oh.
So if I do e to both sides, I get equals 3x minus 9. And how do I get x by itself?
It's 10 equals 3x divided by 3, so 10 thirds.
And I'm just doing my basic algebra stuff. It's 10 over 3 is equal to x.
Is your x?
Correct. You can put it as a decimal if you want. That's fine. That is a-okay.
Wait, so they both are like x equals. I get that one's like intercepted, one's the asymptote, but
Okay, so yeah, this is technically not x equals, technically, because what is it? It's 10 thirds, comma 0. Like it's a point, right?
yeah, okay.
Like a line. X equals means a line. If you forget to put that and you just have the answer down,
Yeah.
technically it's not fully right, but that I'll get that. Because I know you did here. But 10 0 really the x-intercept.
And so for the first one, we just did, it was vertical asymptotes. We set whatever parentheses to 0.
Yes.
And if the other, we actually have to use the ln to find the inner.
You know why I set the inside of the parentheses equal to 0? Remember vertical asymptote, right?
Right.
Changes based on horizontal change.
I just remember that rule that you said that it's like when it's in the parentheses, it goes the opposite way. whatever, that's what.
Correct. Really, y, you're really setting it equal to 0, right?
Yeah.
To solve. So this would be a horizontal change. Gotcha? Which, again, horizontal change affects my vertical asymptote.
Right.
Cool.
Because X is always horizontal and then Y.
There was an exponential and it had a horizontal asymptote, right? That would be affected by vertical change, right? That makes sense? And technically, this yellow line is not the graph of this, is it?
No.
Why? There's one thing wrong with it. So it's here, right? Vertical asymptote of 3. You're right there. The yellow line's the positive version.
Oh,
yeah,
it's
it's negative.
negative. It's
So it
negative.
should be the gray one. Is it?
So-
It flips, right?
Wait, would we have to graph? Or would we just have to?
I don't think I asked you to like just cold turkey say graph it. There might be one where I say, here's the graph. What would that?
Yeah, I don't know how I'm gonna do all
I
this.
just don't understand logs. I really don't. It stresses me out.
Do we feel better?
Yes.
Yeah,
do,
it's
yeah.
better, but
I'll be
Okay,
here
so-
tomorrow at 9 a.m.
So
yeah,
right
I'll be
here-
I'll be here tomorrow.
Right. Well, today we went through half the stuff.
Okay.
Probably, I think we actually went over half the stuff that would be on there.
I will watch the podcast.
Unit,
and I will
unit
figure it
one
out.
and this definitely.
Maybe
I was in
unit
here for
4
5.
tomorrow.
Unit 4 we'll do
Yeah.
tomorrow.
And 2.
We'll probably do the rest of it.
Yeah.
If you're good with that.
And then can we like review other stuff too once we finish this 2 years.
Please, yeah, please. We will definitely do that. I think we have a little bit of logs right here to do. Like some of this is a little bit not as bad. This was what I was talking about with graphing.
Okay.
There's a couple graph stuff I want to hit on. Unit 4 we haven't hit on, but we will. Yeah, we'll do that. Be good.
Sweet. Thanks, Coach Jay.
You're welcome. We'll see y'all.
See you tomorrow.
We'll do. Let me sign out real quick.
Tall Alley?
Hey, y'all. Hope that was helpful today. I know it was long, but we got Unit 5. There's Dory. She came today. A lot of people came. Hope this was helpful for you. Come on in tomorrow morning. We'll do it again, and we'll go through it together. See y'all. Bye.